Assalamualaikum and hi. We are from Group H and our members are Aziza binti Arfian as a leader, Siti Aisyah binti Elias, Nur Syaira binti Mustafa, Nurul Ain binti Ruslan and Nur Zahra Zahira binti Mahdi. And our topic for reviewing thesis is the Kramer-von Mises test statistic of the generalized extreme value distribution and Weibull distribution. Okay, let me start with research problem. The goodness of fit test for the CVM test in the GEV and Weibull distribution is investigated in the dissertation. Many studies have been conducted on a goodness of fit test for the GEV and Weibull distribution. However, there are still inconsistencies and a scarcity of published critical values for both distributions. The findings of this study will be used to assess the CVM test of the GEV distribution and the Weibull distribution on a set of data. Furthermore, the researchers will have the challenge of obtaining the critical value table for each distribution in order to test the appropriate distribution function. To determine how well a goodness of fit test performs against a certain alternative distribution, a critical value table is required. Then, we move to the objective of this research. There are two objectives given. Firstly, to develop calculation critical values of CVM test statistic for GEV distribution and Weibull distribution. In these studies, they will develop formulas and mathematical calculation of critical values by using MathCAD software in computing goodness of fit for the GEV distribution and Weibull distribution. The other objective is to compare the accuracy of CVM tests between GEV distribution and Weibull distribution in real data. Besides, scope of the research is these studies focus on CVM tests for GEV distribution and Weibull distribution. Besides, from these studies, the probability with moments or L moments method is used to obtain the parameter estimation of this distribution, and mathematical calculation of critical value is developed using simulation experiment. And then, a set of rainfall data is applied in order to evaluate the assessment of CVM goodness of fit test using CVM test statistic. In my opinion, they choose an interesting topic when we can know that GEV and Weibull distribution can use to calculate some data, and from both method also we can compare which more accurate. And this research has a good objective which they know what they want to gain, and the research scope also has all what they want to focus and gain from this research.
Significance of study. Study of goodness of fit tests for extreme events is useful to determine the distribution function in modeling extremes of natural phenomena such as floods, wind speeds, and rainfall. This study develops formulas and mathematical calculation of critical values by using MathCAD software in computing the CVM test statistics for two distributions, which are the GEV distribution and Weibull distribution. So, this research helps other researchers in computing critical values for CVM tests in both distributions. Furthermore, a rainfall data is applied to the study in order to know which distribution fit the rainfall data. Thus, the study is useful to know which distribution best fit the rainfall data.
So let's move to the evidence of critical evaluation of existing literature. The goals of this study are to establish a method for calculating the critical value for the CVM test and to evaluate the CVM test accuracy to that of other GOF tests like the Anderson-Darling test and the modified Anderson-Darling test. This test is used a set of annual maximum rainfall data in Peninsula Malaysia as a random sample data. So the GOF test is a useful tool for determining how well a set of this data fits a given probability distribution. In order to test the null hypothesis, so it involves a random sample. The hypothesis is stated as follows. H null is equal to data follows the GEV distribution or Weibull distribution. H1 is equal to data not follows the GEV distribution or Weibull distribution. To avoid wrong decision and interpretation data, it is important to select appropriate distribution. Parameter estimation using probability weighted moments PWM, or we can call it L moments, because it more stable and unbiased results and fast and straightforward to compute the values. Next page. This study only focused on CVM test statistic, the one of method of GOF test, which is based on the cumulative distribution function of the hypothesis distribution to apply these two distributions. First is generalized extreme values GEV distribution, and the second is Weibull distribution. For the GEV distribution, it is extreme values theory produces a family of continuous probability distribution. This distribution uses three parameters, which are a scale parameter alpha, location parameter U, and shape parameter K. For the application, on the research, Shin et al. 2012 evaluated the applicability of the MAD test by using rainfall data in Korea. In this research, GEV distribution is used to fit the observed data with several parameter estimation methods. The result of this study showed that the MAD test is a powerful GOF test for the frequency analysis when extreme cases are considered. For the Weibull distribution, it is a continuous probability distribution. This distribution also uses three parameters, which are scale parameter alpha, location parameter U, and shape parameter K. For the condition of the parameter is when the location parameter is set to 0, the probability density function PDF reduced to that two-parameter Weibull distribution. For the application, on research Dauda et al. 2013 concludes that the Weibull distribution can adequately be used to study the distribution of rainfall in some terms. Next page. Each critical value is compared to the value of each CVM test statistic. So we can have two conditions. First is the test hypothesis is accepted if the estimated value of the test statistic is smaller than the critical value. Meanwhile, if the computed value of a test statistic is larger than the critical value, so the test hypothesis is rejected or the null hypothesis is accepted. It is concluded that the sample data with the highest rejection represent the best rejection performance that fits the data of the distribution. The comment for the evidence of critical evaluation of existing literature. First, based on application of GEV distribution, I agree with the method used, which is CVM test, although the research has shown that MAD test is the powerful test, but we also need to consider on the aspect that we want to test, such as hypothesis distribution, so CVM test is the most suitable test. Second, based on CVM critical value, in my opinion, to get most accurate critical values, so we need to use the small length of the sample size. Third one is both distribution critical values for the CVM test are generated from simulation using MATCAD software. As we can see, the sample size of the data is too big, so MATCAD software is very useful to generate critical values for CVM tests, and we can save time to compute the values.
Assalamualaikum, I'm Aziza binti Arfian and I will proceed reviewing the thesis. So in this thesis, the research design that used in this thesis, I separate it into 6 parts, which is the first part is about the probability distribution. So in this part, this thesis introduced to us two distribution, which is the first one is generalized extreme value GEV distribution. So overall, the general form of the GEV distribution has 3 parameters, which are scale parameter, location parameter, and shape parameter K. And then the second distribution is variable distribution. So a random variable X is a variable distribution if its cumulative distribution function CDF with scale parameter, location parameter, and shape parameter. So variable distribution must be in the CDF, which is cumulative distribution function. The second part in this thesis, the research methodology is about descriptive statistic. So the descriptive statistic of data that used in this thesis is produced by calculating the number of years, mean, variance, standard deviation, minimum and maximum amount of rainfall for each station. So the mean in this thesis represented as the arithmetic average of a set of values or distribution that is used to derive the central tendency of data and represent the average of the data set for all of 75 rainfall stations. And variance is the average value of the square distance from the mean value in probability theory and statistics, while the standard distribution is defined as the average amount by which individual data items in a data set differ from arithmetic mean of all data in the set. So the third part in this research design of this thesis is about parameter estimation. One of the general statistical method in fitting GEV, which is a generalized extreme value distribution, and estimates the parameters of distribution to the data. So why this thesis choose it? Because it is fast, straightforward, and also have some desirable characteristic to compute parameter estimation. So this is to calculate the parameter more accurately. Then in this parameter estimation also, in this part also, this thesis use L moments parameter to estimate GEV distribution and variable distribution. Then the fourth part or the fourth test that is used in this research methodology is goodness of fit test. So it is used to test statistic, Kramer-von Mises test statistic. So what is GOF? GOF is measure to study the discrepancies of empirical distribution function EDF and the hypothesized distribution. So it is useful to verify any distribution to a data by the statistical GOF test, as it describes the fitness of the distribution to the data observation. The Kramer-von Mises test statistic has been suggested to test the goodness of fit for GEV distribution and variable distribution. Besides that, the method in this thesis used is calculation of the critical values. So there is a procedure to use how to calculate and generate the critical value tables for the CVM goodness of fit test. So the first step is this thesis they find for a fixed sample size n and fixed shape parameter, and standard random divides are generated. So the second step is the n random divides are arranged in ascending order of xn, x1, x2, x3 until xn. So the third part is the ordered random divides are used to estimate the parameters of each distribution by using L moments parameter estimation. The fourth step is the CVM test statistic is calculated. The fifth step is the values of the statistic of 19th, 19.5 and the 99 percentiles are used as the critical value. So from the step 2 until step 4, it will be repeated until 5,000 times. And then the last method that this thesis use is power study of GOF test. The power study of goodness of fit test for CVM test statistics is significant to determine the reliability of critical value. So it is defined as the probability of rejection of the assumed null hypothesis H null when it is false. So the power of study of GOF is essential to determine the reliability of the critical values. So here I state the flow chart of power study. So the first step is we must to create a data, we must to collect the data from GEV distribution or Weibel distribution. Then the second part is calculate the test statistic of CVM test for both distribution, Weibel and GEV distribution. And then the third step is compare the calculated test statistic to the critical values. And then the fourth is determine the test hypothesis. Thank you, that's all for me.
There are several things taken to produce a statistical descriptive of which are mean, variance, standard deviation, maximum and minimum amount of annual rainfall. First, the mean or average of annual rainfall data lies between 69.1971 mm per station to 228.3672 mm per station. The variance for all rainfall stations lies between 183.1587 mm to 17,132.17 mm per year. The standard deviations for all the 74 rainfall stations data is in the range of 13.644 mm to 130.8899 mm. The maximum amount of annual rainfall range between 110 mm per year to 800.5 mm per year. The minimum amount of annual rainfall in all 75 stations lies between 12 mm per year to 132.5 mm per year. Now, let's take a look at the analysis and results section. Based on this thesis, the maximum data of annual daily rainfalls for 75 stations in Peninsular Malaysia is considered as a sample to be applied in illustrating the application of GEV distribution, which stands for Generalized Extreme Value, and Weibel distribution by using the L moments approach. Why do we use L moments? To estimate the parameters of the sample data for GEV distributions and Weibel distributions. So the answer is why we use L moments, because it is less biased and low efficiency, less sensitive to random outliers and gross observational errors, and the last one is L moments much more convenient than the maximum likelihood method because it allows one to draw data on the shape of the distribution. So table 5.4 show us that the number of sample data which show the rejection of CVM test statistics for the GEV distribution and the Weibel distribution. Then a power test is performed to compare the rejection rate of the CVM test between the GEV distribution and Weibel distribution. The power of test statistics is defined as the probability of rejection of the assumed null hypothesis. As we can see from the table, it is clearly represented that the Weibel distribution has the greater number of sample data showing rejection of CVM test statistics at three different significance levels, which are 10%, 5%, and 1% significance level. It can be concluded that the result of goodness of fit test using CVM test for this rainfall data in Peninsular Malaysia is most appropriate by using the Weibel distribution
to fit the model of this rainfall data. So after look at the analysis and results on this thesis, I would say that further research can be done by compare the difference between several distributions such as generalized logistic distribution, which is short form GLO, exponential distribution and others. And lastly, further research can for testing GEV distribution and Weibull distribution also can be applied to the other fields of study as well. This is because the distributions are not only relevant in rainfall datasets, as it can also be used in flood, wind, and so on.
Conclusion: assessing the goodness of fit GOF test of a proposed probability model is a fundamental concern in the application of statistical methods. The GOF test has been applied widely in the area of applied statistics. There are a lot of research has been carried out to compare the efficiency of several GOF test procedures. Generally, the GOF test statistics measure the degree of agreement between the distribution of an observed sample data and a theoretical statistical distribution. In this study, the GEV distributions and Weibull distribution are used as the theoretical statistical distribution, where to test the data follow the both distributions. In order to calculate the GOF test statistics of the distributions, a sample estimate of those distributions requires estimation of the three parameters, which are scale parameter, location parameter U, and shape parameter K. The L moment method is used to compute all the parameters. The purpose of this study is to generate the critical values of the CVM test statistics for the GEV distribution and Weibull distribution by using simulation experiment. The data of annual maximum rainfall has been applied to evaluate the applicability of CVM test statistics. Then, power test is performed to compare the rejection rate of CVM test between the GEV distribution and Weibull distribution. The results show that the Weibull distribution has greater the rejection rate compared to the GEV distribution. The result of goodness of fit test using the CVM test statistic shows that the Weibull distribution has the greater rejection power at three different significance levels compared to the GEV distribution. It can be concluded that the result of goodness of fit test using CVM test for this rainfall data in Peninsular Malaysia is most appropriate by using the Weibull distribution to fit the model of this rainfall data.